What date is today? Today is 1st of August. You are gradually reaching to your target 8/1/2021. You can hear. Today is 1st of August. You are gradually reaching to your target. Right. We are talking about the second unit of grade 10, that is graphical representation. Graphical representation of motion in a straight line. Um, in this unit, actually, we discuss about the displacement and time. So let me see you what we have been discussing. We wanted to know about these three things. First one, speed related with the speed, which is related with the distance and time. So it is between distance and time. And second one, we want to talk about the velocity. That velocity comes with displacement and time. Displacement and time. And then third one is acceleration. Acceleration is between the velocity and time. So these are the key features of the second unit. When we discuss about these three features, we can connect the other lessons, that is the Newton's law of motion. The related other lessons are Newton's laws of motion. We can connect with this lesson, laws of motion, especially F equal ma. There you can see that F equal ma. So the key point, as I told you here, acceleration. So the acceleration is here we are discussing, and the force required to give an acceleration to a certain mass is discussed here. So you can take that one. And the other one is momentum. Momentum, mv. You can see that momentum, not moment, momentum, mv. So there you can see velocity is discussed. So that one also related with this. You can have the link with this one. So basically, this is to study about the velocity, acceleration, deceleration, and displacement. We just have already started the first part, and we discussed certain questions under that one. Of course, last Sunday we couldn't do the lessons because of the electricity failure. And today I hope to continue with these graphical representations with the displacement and the time, graphical representation between the with the velocity and time. So let's continue with that. We have discussed some questions as well. So I hope that you are okay with this. Good morning and have a nice day, Suindu. You came late now. Well, this is my next question. Starting with the simple one and then to go to the complex part. Starting from the simple to the complex part. So we have discussed 9 questions under that, 9 major questions. So this is the 10th one, the 10th question.
Are you okay with that? Question number 10.
Okay.
Question number 10. Start in 8 the August. Question number 10. Given below, given below is a displacement time graph. Given below is a displacement time graph. Answer the question. Answer the questions based on the graph. Answer the questions based on the graph. Given below is a displacement time graph. Answer the questions based on the graph. All right. This is the graph. This is the graph. I will select blue color. It has two axes, right? This is displacement in meters, time in second, 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Displacement time graph. So it starts something like this. It starts something like this, and then continues right here, and then it comes to this position. So this is the moment, and I'm going to put the time 2, 4, 6, 8, 10, 12, 16, 18 seconds. Right. 5, 5, 10, 15, 20, 25, and 30. 5, 10, 15, 20, 25, 30. So you can have a graph like this. My first question, the first part of this, right? Um, what is the initial velocity? What is the initial velocity? What is the initial velocity? Second question, I'm sorry, not it is velocity. What is the initial displacement? Displacement. What is the initial displacement? Second, what is the nature of the motion? What is the nature of the motion? between 0 second to 6 second. That's simple A. Simple B, 6 second to 12 second. C, 12 second to 18 second. 18 second. Third question. What is the distance traveled within? What is the distance traveled within 0 second to 6 second? That's A. B, 6 second to 12 second. C, 12 second to 18 second. And question number 4. Question number 4. Find the magnitude of the motion. Find the magnitude of the motion from 0 second to 6 second. 0 second to 6 second. That's A. And B, 0 second to 12 second. 0 second to 12 second. C, 12 second to 18 second. 18 second. Right. 3, 4. And 5. Draw a velocity time graph. Draw a velocity time graph. Draw a velocity time graph for. Draw a velocity time graph for 0 for the motion. From 0 second to 6 second. 0 second to 6 second. And 5, 6. What can you tell about the resultant, resultant, resultant force acting on the object, between 0 second to 6 second. 0 second to 6 second. 6 second. 7. Give your reason. Give your reason for the sixth answer. Give your reason for the sixth answer. So we are talking about a big question. This is about the graph based on the displacement time graph. Okay. Right. This is the question. Sorry about the latecomers. I'm going to take this one onto a screen and going to stop sharing. Okay. Right. Now let's turn into this one. I'm going to use this one. Here is this one. Here is this one. Okay. We are discussing about the displacement time graph, and we'll draw the displacement time graph given here. It is something like this. It is something like this one. Right. Are you okay with this all? No problem? Fine.
Okay. Okay, sir.
No problem. Good. If this sounds not work, you can look and listen very well. Okay. I'm going to draw the displacement time graph. You have the y-axis and then you have the x-axis, right? Then this is 0. This is time in second, and this is, what is it? Displacement. Displacement in meters. Displacement in meters. And I put time intervals as 2, 4. May I use background with this one? Then it is pretty easy. 2, 4, 6. What's the other one? 8. Then 10, 12, 16, I think. 16, 18. Right. Here it is from 5, right? 5. 1, 2, 3, 1, 2, 3, 5. 10, 1, 2, 3. 15, 20, 25, I think 30. That's how it went on. And when 0, it is 15 here. And then 4, no, 6, 25, 6, 25, 6, 25, and 12, 25, 12, 25. When it is 12, it is 25. Good. And next one, 18, 0. So you have a graph like this. You have a graph like this. graph. Right. Based on this only, we are going to discuss about the question. Okay. Yeah, the very first question is, what is the initial displacement? What's the initial displacement? What do you mean by initial? Initial කියන්නේ මොකක්ද? What do you mean by initial? The start, the beginning. So what is the displacement at the initial position? Your answer? Your answer?
Meters in the particular direction.
Yeah. It is. Now you can have, as that little girl told, you can have a 15 on the other side as well. So I have not put that one. You can have 15 on the other side as well. So if I extend this one further, so you can have a 15 in this way as well. So somewhere 15 here. So there can be two 15s. This is negative 15. This is positive 15. What is the initial velocity? I told you that if you are joining with me the revision class, definitely you have to answer my question. If you are coming just to see and observe what's happening here, this is not a drama for you to, I'm not acting a drama for you to see and enjoy and then go, right? You can see a drama on the stage. The actors are coming and acting, you're not going to contribute with them. But this is not a drama. Getting up early in the morning, like 4 o'clock. Okay. It should be a two-way communication. So definitely I need your answer. Okay. If you are unable to answer the questions, better you get back into the bed and sleep because you can have more time. It's 4:30. Yeah. What is the initial velocity?
15 meters in the particular direction.
What about the others?
Same answer, sir.
Same answer. Yeah. 15 meters to the particular direction because this direction is opposite. And this is to the particular direction. To the particular direction. And this is opposite. I mean, if I am facing your way, this is the particular direction. And if I turn back, and that is my opposite direction, right? Opposite direction. So the first question is, what is the initial displacement? So when the time is 0, the displacement is 15 meters. The first answer for the first question. Answer for the first question. 15. It is 15 meters. 15 meters to the particular direction. Particular direction. 15 meters to the particular direction. අදාළ දිසාවට meter 15. 15 meters. My second question is, what is the nature of the motion between 0 second to 6 second? එහෙනම් මෙතන කොහොමද 0 second to 6 second. මෙන්න මේ displacement එක ගැනයි අහන්නේ. Nature of the motion. So you can see that the displacement is gradually increased. The displacement is gradually increased, right? You can have something like this, or something like this, or something like this. You can have different methods, but this is the gradual displacement, gradually increased. When displacement is increased from one value to the other, right? Gradually, and that's the rate of change of displacement. Rate of change of displacement is velocity. Velocity. So the velocity is increased, and that increase, the way of increasing is also gradual. The other way around, you can say, if you consider the gradient, if you consider the gradient m, we call m, we can see that m tan theta m equal y over x, y axis divided by x-axis. You can see the gradient is given. The gradient also gives you the velocity. So the answer for the second part, first question, 0 second to 6 second, the displacement shown by, or the motion, the nature of the motion is constant velocity. It is constant velocity. Constant velocity, or we call uniform velocity. The velocity is uniform, gradually changed. My second one, 6 second to 12 second. 6 second to 12 second. That means during this particular period, right? So if you consider that the gradient of the graph over here is no value, it's 0. When the gradient is 0 means that no displacement is taken place. See, when the time is 6 seconds, the displacement is 25. And you consider at 10th, 12th, and 12th second, right? The displacement is still 25. That means the object has not moved. So my answer for that one is that object is stationary. Object is at rest. Object is at rest. It's resting. It's not moving. It's kept over there without any movement. And when my next part is 12 second to 18 second. 12 second to 18 second. So there you can have the declining, reducing. The 25 displacement is brought back to the 0 position. 0 position of the displacement. Time is taken. Time is the independent variable here. It independently changing. It independently changing. And my answer for the 12 second to 18 second is 12 second to 18 second. As discussed earlier, it is also gradually decreasing and the gradient is there. So the answer is constant velocity or uniform velocity. Constant velocity. Right. So that is the answers for the second question. Moving to the third question. What is the distance traveled within? Right. The distance traveled within 0 second to 6 second. What is the distance traveled? My third question. What is the distance traveled within 0 second to 6 second? 0 to 6 seconds. What is the distance traveled? Yeah, what is your answer? What is the distance traveled from 0 second to 6 seconds? What is your answer, just to get an idea about how you understand it?
30 meters.
30
Meters.
meters. Any other answer? Any other answer? Please don't be just a participant and be a visitor. You can join with the YouTube and then find out. You are invited to the Zoom class. It's for interactive sessions, right? I'm asking is from 0 second to 6 second. 0 second to 6 second, the distance that the object travels. Yeah. No answer. You are suggesting me to end the session.
In meters.
Again,
In meters.
10 meters, 30 meters, 10 meters. Any other answer? I kindly invite you, join with us. If you can speak only, switch on your mic and speak only. Join with otherwise, yeah. Randunu, what is your answer?
Sir, 10 meters.
Oh, yeah, you told me that. Yeah. Buddhima? What is the answer? I didn't hear. Menushi? I can't hear you. I can see that mic is. Huh?
10 meters.
If you say don't know, yeah, could you please show me that we don't know? Put a hand mark that if you don't know, at least to get an idea. Don't be dead bodies, like no response, no
No,
nothing.
sir.
What about the others? Yeah. Now look at here. The distance it traveled within 0 second to 6 second, right? The distance is calculated. This is displacement time graph. You must not mix up these two, velocity time graph and displacement time graph. Don't mix up that. The distance, I'm going away from this graph for a while. I'm going away from this graph for a while. And look at here. There you got two graphs. I'm going to give you two graphs. This is of course displacement time graph. So you can have the displacement time graph. This is displacement, and this is time. And the same time you can have the velocity time graph as well. And this is velocity time graph. Velocity time graph, right? This is velocity. And this is time. So velocity, time is there. Displacement time graph, right? The distance the distance it travel is calculated only by going up and down. So you can go up and down and then find out the answer. 1 second. I don't know what happened to this, my mic. It should come over here, right? Like that here. Displacement time graph, the distance is calculated. You go up and down, up, down. Calculate that, something like this. If you say here, like 0, and this is 25, right? So you can have the time. So if the motion is displayed by up, go, down, right? So the distance is calculated. Take the displacement up. It is 25 meters. And then down. Along with the time, the object comes to the initial position. It moves up and then comes to the initial position. So it went up 25 meters and came back 25 meters. So the 25 meter is added and the total is 50 meters. So the total motion of this object is up 25 and down 25. Altogether it is 50 meters. What I'm asking is the distance. Okay. So that is displacement time graph. But when you consider it is velocity time graph and the motion is the same, move, come back. And if this is 25 and certain time, let's consider this is 20 seconds. Now you can't find out that this like displacement go up and down. No, that's difference. From here, if you want to find out the displacement, what you have to do is to find out the area of the graph, area of the area depicted by the graph. For that, if you consider this length is A and this length is B, so the height is H, right? The distance can be calculated A plus B divided by 2 multiplied by H. So this equation would give you the distance traveled by the particular object during that particular period of time. So there it is not 25 plus 25, 50. So you have to A, I have not given you the value of A and B. So likewise, you can find out the distance it traveled. So this is the difference between the displacement time graph and velocity time graph and the distance traveled within the particular period of time given to you, right? And with that knowledge, let's go back to our question. I have given you the question. We wrote the question earlier. What I'm asking is the distance traveled within 0 second to 6 second. 0 second to 6 second. So there you can see it went up it went up within the particular period. So the distance it traveled is here. It has 5 meters, another 5 meters, 5 meters, 5 meters. So the answer, your answer is 10 meters is correct. So the distance it traveled is 10 meters because it moved up within that particular period. My next question is 6 second to 6 second to 12 second. 6 second to 12 second. See whether you can move up and down along with the y-axis. You can't. You can't because it is always the same. So the within 6 to 12 second, the distance it moved is 0 meters. 0 meters. It does not move. Next one. As we told that object is at rest, means that its distance is 0 meters. And the next one is from 12 to 18 seconds. 12 seconds to 18 seconds. All right, now you can have the displacement because starting it moves down. You can find out the displacement by using your two hands, right? So you give your right hand to go along with the time, right? You keep the time here, your right hand, and then take your hand to the displacement, the particular displacement. අපි කතා කරන initial තැනට යන්න, අත මෙහාට යනකොට එයා මෙහාට එනවා. ඒ කියන්නේ එයා ගිහින් තියෙනවා how many? 25 meters. It went 25 meters. So then what is the total distance it traveled within the particular whole period of time considered? The total distance it traveled within the particular period of time considered. You can see the first, within first 6 seconds, it went 10 meters and then stayed there without coming or going, and then started to come back. Is 25 meters. So altogether, the total distance is 35 meters. The total distance is 35 meters. And moving to the other question. What is the distance traveled within? Yeah, that's the third one we answered. Find the magnitude of the motion from 0 second to 6 second. Magnitude of the motion. Now, magnitude of the motion. Do you, try to find out. I'm going to use this part to write the answer for that one. Magnitude from 0 second to 6 second. 0 second to 6 second. What is the magnitude? How can I find? So the magnitude actually is given by the gradient of the graph, right? Because we draw this straight line y equal mx plus c, then we can see that m equal y upon x, or no. Change in y, change in y divided by change in x, change in y, this is, and change in x. Change in y, 25 minus 15, 25 meters minus 15 meters. Change in x means, right, 6 second and 0 second. 0 second. 25, take 15 out of 25, it is 10 meters, and here it is 6 second. So you can have the answer. What is the answer? 1 point. There are 4, right? 1 point. Help me in answer. 1.6 meters per second. Meters per second. Meters per second. 1.6 meters per second. Right. So that means during this particular period, the magnitude of the motion is 1.6 meters per second. Actually, it is the constant velocity. Then 6 second to 12 second. 6 second to 12 second. 6 second to 12 second. You can have the answer in 2 ways. You can have the answer in 2 ways. Let me see how I explain it. Magnitude of this particular period, right here, that is 6 second, 6 second to 12 second, 6 second to 12 second, 6 second to 12 second. You can have the this one. I will say m equal change in y, change in y, and change in x, change in x. You don't want to write the answer in the same way that I drew for this part, but I'm going to show you what happened now. Change in y. So is there any change in y?
No, sir.
No. So it is 0 meters. Is there any change in x?
No, sir.
Y. You can have the change in x. What is it? The x is changed from 6 second to 12 second. So you can have 12 second minus 6 second. But when it is 6 second, right? 6 second divided by 0 meters. So the answer, you can't divide 0 by 6. The answer is 0 meters per second. 0 meters per second. You don't want to find the answer in this way, but I just explain you the magnitude of the motion when the displacement time graph takes the shape of this way. So it is 0 meters per second, the answer. There is only that there's no motion, so change in y. No, there's no any change in y. That's why I put 0 meters. But there is change in time, x. That's 12 second upon minus 6 second. My next question is 12 second to 18 second. 12 second to 18 second. There is a change. 12 second to 18 second. So I'm going to use this space for that one. I'm going to use this space for that. Going to clean. Right. So this is 12 second to 12 second to 18 second. 12 second to 18 second. As usual, magnitude equal m equal y upon change in y upon change in x, change in y divided by change in x. Change in y, now you have change in y. How are you going to write it? Change in y. Initial y, final y. Initial y is now, what is it? What is the we want to find out change in y, final y minus initial y, not initial y minus final y. The initial value is taken by considering the time, 12 seconds. By that time, the velocity, the displacement is 25. Final, it means when the time is 18, the displacement is 0. So you have to write here, final change in y means final final y minus initial y, and final x minus initial x. So finding out final x. මෙයාගේ final x එක කීයද? නෑ final y. Final y කියන්නේ 0. So then you write 0 meters. Initial එක started at 25. මෙතන 0. Initial එක 25. 25 meters. 25 meters. Right? Final x, 18 seconds. The initial, not 0, but within particular time interval. Initial is 12 seconds. Then the top one is negative 25 meters upon 6 seconds. Upon 6 seconds. Negative 25 meters upon 6 seconds. What's the answer? Oh, it takes the negative value. 4.1 meters per second. Meters per second. You can write the answer like this. 4.1 meters divided by second. And this one is indicated as meters per second likewise. So the value takes negative means the velocity is to the opposite direction. It's constant velocity and it moves to the opposite direction. Moves to the opposite direction with the uniform velocity. And that's all about that part. So we are talking about these questions for the latecomers. We have been discussing about some answers here. Then the magnitude of the motion from 0 second to 6 second. Draw a velocity time graph for the motion from 0 second to 6 second. Now, we are asked to draw, okay, we are asked to draw the velocity time graph for this one. Let me clean and find out the space for me to write, right? A space for me to write. Space for me to write. Okay. We are asked to draw a velocity time graph for this part. Velocity time graph, right? When drawing a velocity time graph, what is the time interval we have to consider? Time interval 0 to 6 seconds. 0 second to 6 seconds. And the velocity is always what? Which value? We found out the gradient in this occasion. And it was, what was the value? 0 second to 6 seconds. What is it? 1.6 meters per
1.6
second.
meters per second.
Yeah, 1.6 meters per second. So what I'm going to draw for that is So the velocity time graph, you can have the graph like here, y-axis and x-axis. Y-axis and you have the x-axis. Not y, it should be velocity, meters per second, time, second. This is 0, should be mentioned. And the value is, we saw that magnitude, මෙයා මෙහෙම තිබුණාට එයාගේ අගය 1.6 meters. එනම් මට පුළුවන් මෙතන 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the other way it is, you can write 2, 4, 6. 2, 4, 6. It should be 1.6 somewhere here. And take the graph. Its constant value, unchangeable, up to 6 meters. So the particular graph is like this. Particular graph, velocity time graph is like this. It's always the constant value. When whatever the time interval you consider, the value is 1.6. 1.6. Whatever the time interval you consider, the value is 1.6, 1.6, 1.6. So it continuously changes, and this is constant velocity. Draw a velocity time graph for the magnitude of from 0 second to 6 second. What can you tell about the resultant force acting on the object between 6 second to 0 second to 6 second? Well, if the object moves with the constant velocity, right, what is the resultant force acting on that object? What can you tell about the resultant force? Your answer is? If an object is moving with the constant velocity, uniform velocity, what is the resultant force acting on that? Is there a force towards the motion, or is there any force, the resultant force, right, to the opposite direction, or the resultant force is 0? What is the answer? And don't forget that I'm asking the reason for that from my next question. Give you a reason for the 6th answer. Let me know, what can you tell about the resultant force when an object is moving with the constant velocity? Being silent is not acceptable. Telling any of the answer is highly appreciated. You necessarily don't want to be the correct answer. If you know exactly the correct answer for almost all questions, you don't want to come over here and waste your time. Yeah, what is the answer?
0.
I couldn't hear.
0.
Yeah, you say constant, the resultant force is 0. Yeah, the answer is, the resultant force is 0 Newton. The resultant force, 6th one, 6th answer, the resultant force is 0 Newton. 0 Newton. Give you a reason for the 6th answer. Why do you say it is 0 Newton? ඉස්සරහට යනකොට ඒකට ෆෝස් එකක් ඇප්ලයි වෙන්නේ නැද්ද? No force when it moves forward? Yeah.
Because it is constant.
Yeah. How do you know it? What is the clue that you are using? In Newton, huh?
Newton's
Yes.
first law of motion.
Newton's first law of motion says that until an unbalanced force is applied on, right? Until an unbalanced force is applied on, the object at rest, staying at rest, an object with the uniform velocity keeps moving with the same velocity until an unbalanced force is applied. So that means when the object is at rest, like here, when the object is at rest, the force acting on the resultant force is zero, because when the object is at rest, it has two forces, the W and upward perpendicular reaction. So when I am standing here, the W, my weight is there acting downwards, and the ground exerts upward force, which is exactly similar to my weight. So W equal R. So the resultant force is zero. My W, if we say W is, if I am 65 kilogram, 650 Newton. 650 Newton downward, 650 Newton upward. So the resultant force is zero because there is no motion. In the same way, when the object is moving with the constant or uniform velocity, the forces acting on it is balanced, forward, backward, balanced. Therefore, it keeps moving with the uniform velocity. So, what is the reason for your answer? The reason for your answer is, oh, Newton's first law of motion. Newton's first law of motion indicates the forces acting on an object with uniform velocity has balanced forces. Object with uniform velocity has balanced forces. Right. There you are. And my next question, give you a reason for the above answer. Yeah, we have already all discussed. Am I correct? We have discussed all. Am I correct?
Yes.
Oh,
Yes, sir.
right. This is the question. It's a big question. Am I correct? Let's see. Moving to another one. Moving to another question. Yeah. So this is the question we have been discussing. And can go to the other one. 11th question. 11th question. Question 11. Will we write? Shall we write? Shall we write? The graph given below, the graph given below is a velocity time graph, velocity time graph for the motion of an object, for the motion of an object which has 30 kilogram mass, or which has the mass of 30 kilogram. Right. This time I'm not going to give you a big question. X-axis, a y-axis, and the x-axis. So this is velocity, meters per second, time, second, 0. This is the graph. This is the graph. This is the graph. And this is 10, 20, 20. මෙතන තියෙනවා 90. Yeah, the time is I don't like to waste my time, my dear. While you are coming over here to learn, not to listen to the stories, right? I will put 5, 15, 20, 25. Right. කම්මැලිකම එන්නේ ඇයි? මම මැසේජ් එකක් දානවා. So කම්මැලි. එහෙම නේද මගේ මැසේජ් එක ආවේ. ඉතින් කම්මැලි වෙන්න මට කොච්චර කම්මැලියක්ද නේද? මෙතන මේක තනියම කියවන්න. හරි. අපි මේ තියෙන graph එකේ බලමු මෙන්න මේ ප්‍රශ්න ටිකට උත්තර. පළවෙනි ප්‍රශ්නේ. First one. I'm asking usual one, what is the initial velocity? What is the initial velocity? Second one. What is the final velocity? What is the final velocity? Third one. Third one. What is the nature of the motion? What is the nature of the motion between 0 second to 20 second? Fourth one. Find the value of the above motion. Find the value of the above motion. 5. calculate the force acting. Calculate the force acting on the object to achieve 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 the velocity of 20 meters per second from 10 meters per second. Yeah, I will give you a little time for you to find the answers before discussing it. If you are clever enough, within just 1 second, 1 minute, 2 minutes. What is the initial velocity? You can have the answers, no problem. Did you get the answers? Got the answers? Yes or not yet?
Okay.
Finish your drawing, writing, answering. Yes.
Sir.
Finish your answering. What's that? Yeah. This is the question, right? All right. As you can see, what is the initial velocity? What is the initial velocity? What is the initial velocity? The answer?
10 meters per second.
10 meters per second. This is the initial, this is velocity and time, second, meters per second. Initial velocity is this one and it is 10 meters per second. What is the final velocity? Yeah, when 20 it is 20 meters per second. 20 meters per second. What is the nature of the motion between 0 second to 20 second? Nature of the motion from 0 second to 20 second. What is the nature of the motion? What is this motion?
Acceleration.
Again?
Acceleration.
Yeah, acceleration is okay, but what sort of acceleration is it?
Uniform acceleration.
Uniform acceleration.
Uniform acceleration. Uniform acceleration. And the fourth one, find the value of the above motion. Now, what sort of equation should I put to find the value? What sort of yeah, Markian? Mono equation.
Gradient of the graphical change in y divided by
Change in y, change in x. එහෙම නැත්නම් අපිට කියන්න බැයිද acceleration equal change in velocity divided by change in time? Acceleration පුළුවන්. ඇති acceleration නේ උතන දෙන්නේ. නේද? Acceleration සමානයි change in velocity divided by change in time. ඒක ගන්න බැයිද පුළුවන්ද? උත්තරය බෑ. හේතුව මොකද්ද? This is graphical representation. You are asked to find by using a graph, right? So what you have to refer to the y-axis value and the x-axis value, right? So you can't use it change in velocity, change in time. No, what you have to write here is finding the value, right? So the value is gradient. Value is the gradient. How can I find out the gradient? Gradient කොච්චරක් මෙයා ආනතද නේද? y equal mx plus c. අපි අඳින්නේ එහෙමනේ y equal mx එහෙනම් m සමානයි y divide by x නේ. සරල රේඛාවක් නේ අඳලා තියෙන්නේ අපි. නේද? එතකොට y divide by x එහෙනම් අපි ලියනවා මෙතන gradient a කියන්නේ m. M equal change in y divide by change in x. Change in y divide by change in x. Change in y කියලා කියන්නේ final velocity, initial velocity. ඒතර final velocity කියන්නේ 20. එහෙනම් මං ආයෙත් එකක් ලියන්නම් final y minus initial y upon final x initial x. Final x initial x. So we know final y is 20 meters per second and initial 10 meters per second. Final x කියලා කියන්නේ 20 second. Initial 0 second. The answer is 10 meters per second upon 20 second. And that indicates 0.5 meters per second squared. 0.5 meters per second squared. Based on that, the next question is asked. Calculate the force acting on the above object to achieve the above velocity. 20 meters per second, 10 meters per second indala 20 meters per second dakwa වැඩි වෙන්න. To bring the velocity up from 10 meters per second to 20 meters per second. What is the external force that you have to apply to make it an unbalanced force? So we can find out that by how? What is the equation that I have to use?
F equals ma.
What's it? Tell me again.
F equal M.
F equal ma. F equal ma. We know mass. Mass is, what is the mass of the object? 30 kilogram. V equal, sorry, give me 1 second. This is the fifth question. M equal 30 kilogram. M equal, F equal ma. F we don't know. Acceleration 0.5 meters per second squared. So F equal ma are Newton's second law of motion, and then M 30 kilogram and A 0.5 meters per second. 0.5 meters per second squared. That means 15 newtons. You want to have the 15 Newton force towards the particular direction in order to achieve the acceleration up to this point. Okay. We can go to another question. Right. This is my next question. Next question. Based on velocity time graphs. The graphical representation, second unit, we are doing the revision for grade 11 GCE O-level members getting ready for the exam. But this time we considered the second unit of grade 10, discussing about that. Right. Question number 12. Question number 12. Question number 12. Use the information provided by velocity time graph and answer the questions. Answer the questions. This is the velocity time graph. This is the velocity time graph and answer the question. Velocity time in second, meters per second, 0. Goes there, goes this way, and comes back. Right. 0, this is 15 meters per second. This is also, right, yeah. 5, 10, 15. I must say this is 20, 25, 30. 10. This also. And then you get the other way around. Right. My first question. First question. What is the initial velocity? Second question. Find the acceleration of the object within WITHIN 0 second to 10 second. Third one. If if 20 Newton force if 20 Newton force is applied to achieve the above above acceleration, find the mass of the object. Find the mass of the object. What is the distance traveled within 10 seconds to 20 seconds? 5. Find the momentum of the object during 10 seconds to 20 seconds. 6. Find the force applied to bring the object to rest position from 15 meters per second, from 15 meters per second, from the velocity of 15 meters per second. From the velocity of 15 meters per second. 15 meters per second. I will give you a little time to find the answer. Get your answer. Can we go to the answers? Yeah. Can we? Um, yes. What is the first answer? What is the initial velocity? What is the initial velocity?
0 meters per second.
Yeah, it starts at the rate, 0 meters per second. Find the acceleration of the object within 0 to 10 seconds. 0 to 10 second වලදී acceleration එක අහන්න. මොකද්ද මම ලියන්න ඕන equation එක? Acceleration equal
Gradient equals change in y divided by change in x.
I can අනිවාර්යයෙන්ම අපි ලියන්න ඕන equation එක change in
Change in y divided by change in x.
change in y divided by change in x. Acceleration equal change in velocity divided by change in time කියලා ලියන්න එපා. මේක graph එකක් ඒ නිසා එහෙම ලියන්න. 25 meters per second, 0 meters per second upon 10 seconds, 0 second. එහෙනම් 25 upon 10 equal 2.5 meters per second squared. 2.5 meters per second squared. Then, if 20 Newton force is applied to achieve the above acceleration, find the mass of the object. මෙච්චරක් ගන්න 20 Newton යොදලා තියෙනවා. එහෙනම් අපිට අහන්නේ mass එක object එකේ. We know that, sorry, we can write that. Yeah, if F equal ma, m we don't know, acceleration we know, 2.5 meters per second squared. F also we know, F is how many Newton is applied? How much? What is the force applied? 20 Newton force. Then we can write F equal ma, Newton second law. Then we can write m equal F divided by a. F කියලා කියන්නේ 20 Newton divided by 2.5. උත්තරේ කීයක් එනවද? 2.5. The answer is 8 kilograms. Mass එක kilogram වලින් අහන්නේ නේ. ඔව් 8 kilogram. හරිනේ. 8 kilogram. So then, fourth question. What is the distance traveled within the 10 second to 20 second? එහෙනම් distance එක අහනවා 10 to 20 second. මෙන්න මේක. මේ කාල පරාසය තුල ඒ කාල පරාසය තුල එයා ගමන් කරපු දුර අහන්න. එහෙනම් දුර අපි හොයන්න පුළුවන් area of the graph. So I will go to the other side. Fourth question. Distance equal area of the graph. Area of the graph. ඒ graph එකේ area එකයි අහන්නේ. area එක අපිට ගන්න පුළුවන්. මෙතන අපි A කියලා කිව්වොත් එහෙනම් මෙයා B කියලා H කියලා ගත්තොත් නේද? මෙතන මේ ප්‍රමාණය අපි B කියලා ගත්තොත් එහෙනම් A plus B divided by 2 multiplied by X. එහෙම ඕනේ නැහැ මේකේ. කෙලින්ම මේ ස්ක්වයර් එකේ අගය ගන්න පුළුවන් නේද? මෙතන අගය කීයද? 25යි. මේ අගය මෙතන අගය කීයද? 5යි 10යි නේ. 10 වැඩි කිරීම 25. ආයෙ දෙකෙන් බෙදලා ඉන්න ඕන නැහැ. කෙලින්ම අපිට පුළුවන් area of the graph 25A multiplied by A. A කියන්නේ 25 නෑ 20 නෑ. මොකද කියන්නේ 10 නේද? 5 10. කොහේ ළමයි? What is the distance here?
10.
10 ඔයගොල්ලෝ contribute කරන්න ඊට පස්සේ කියනවා අනේ කම්මැලි කියලා. ඒකෝ ගාන මොනවා හරි කියලා නේද? 10 multiplied by 25. උත්තරය 250 meters. ඊට පස්සේ කියන්නේ find the momentum of the object during 10 seconds to 20 seconds. Momentum සමානයි මොකක්ද අපි කියන්නේ? Momentum 5. Momentum equal mv. Now we know m mass එක කීයද? 8 kilogram. හොයාගත්තා ඒක. velocity කීයද මෙතන? මේ කාල පරාසයෙන් moment එකනේ අහන්නේ. What's the velocity?
25 meters per second.
25 meters per second. So 8 times 25 200 kilogram meters per second. 25 400යි 8ක් 200යි. And find the force applied to bring the object to rest position from the velocity of 15 meters per second. Last part. මෙන්න මෙතනලා මෙතෙන්ට gain apply කරපු force එකයි අහන්නේ. Right? It is a little bit longer one because we want to find out first the acceleration or the deceleration, and then you have to find out the force that you have to apply by using F equal ma. So there are two steps. One, first find out. This is 5-6 question. 4-5-6 question. Yeah. First, you have to find out the deceleration of this one, right? As we want to use F equal ma, and we know m, but we don't know acceleration, we don't know f. So there are two unknown factors here. Let's find out first the acceleration. So acceleration or the deceleration here equal change in y divided by change in x. Change in y क्या final minus initial. Final velocity is 0 meters per second. Initial is 25 meters per second. Change in x, 10, right? 10, 30 second minus 20 second. So you have negative 25 meters per second upon 10 second. That means negative 2.5 meters per second squared. So the first work is done. The first part is done. That is to find out the acceleration. Now it is done. And we know m, we know acceleration. Now we can find out force. And F equal ma. What is the mass? 8
8
kilogram.
kilogram.
8 kilogram multiplied by acceleration we found out. Negative 2.5 meters per second squared. We want to write negative value because this is acceleration, sorry, deceleration. So the force you have to apply it opposite to the motion. That's why for negative value is very important. So then you can see that 8 times 25 is 100, negative 100 Newton. Negative 100 Newton. It means 100 means 20 Newton. Isn't it?
20 Newton.
20 Newton. Yes, 20 Newton. So you can say that a force of 20 Newton is applied. A force of 20 Newton is applied against the direction of the motion. Against the direction of the motion. A force of 20 Newton is applied against the direction of the motion. Right. That's the end of the today's session. I hope that you got a certain knowledge on this part. And you can watch again if you have lost a certain part. But I do believe that if you can join live with the Zoom class on Sunday from 4 a.m. to 6 a.m., this is totally free of charge. Anybody can join with us and improve your improve your knowledge. We have been discussing from the grade 10 units. We have already completed the first unit, and now we are finishing the second unit. Next day will be the 3, 4, 5 unit of grade 10 first part. So the journey is direct into your O-level exam. I'm helping you in my capacity by using almost all these technological appliances, right? Please participate, take part actively, and we'll try to discuss some questions that came to your O-level exam from 2016 onwards, from the second unit of grade 10. thinking of that for the next day. I'm saying goodbye. Have a nice day.
Thank you, sir. Goodbye.
Goodbye, sir. Have a nice day,
Yes,
sir.
sir. Goodbye, sir.
Thank you, sir.
sir.
Goodbye.
Goodbye, sir.
See you again. Bye bye.
Goodbye, sir. Have a nice day, sir.
Thank you.
You too. Bye.
Yes, sir. Have a good day.
You too.